Right. Right. Have you all got the notes I sent? Yeah.
Differentiation.
Yeah. Rules of differentiation. Yeah.
Yeah.
So what we're going to do is pick up today a little bit where we left off last time, which is differentiating sine, cosine, exponential, natural log functions. Yeah. So then we're going to look at some rules of differentiation, which is the product rule, where we have one function multiplied by another function, and the quotient rule, where we got one function divided by another, and then the chain rule, which is where we got a function within another function. Right, so that'll become a bit clearer nearer the time. All right, you all happy with that?
Oh, pretty happy. Can't see much on your whiteboard. If
No, I know. Hang on, let me unshare that for a minute. I'll share this. Share what I got on the screen.
Oh yeah, now we're talking. So
that's the file we're working with. So I've included your a shortened version of the table of standard derivatives that was issued with the last notes there. And what we're going to look at now is how we find the differential coefficients of sine and cosine functions. Yeah.
Yeah.
All right. So we switch over to. Well, I'll tell you what. Using the table, this table. So if we look at the sine function, if we've got a sine of some constant a multiplied by x, the differential of that, dy by dx, is a, so the a comes outside, and then we have the cosine of a times x. So that's how it works. Yeah. So we bring a out and multiply. So if there's a 3 in front of this cosine, this sine, then we multiply it, that becomes 3a cosine of ax. And then doing a cosine differential, we take a out and it becomes minus a times the sine of ax. So have a go at those two problems for about 5 minutes, and I'll see if I can sort this out and get the right file across to my iPad. All right?
All right. Say Nizzy.
Pause there. You didn't remind me, Dom, did you? So just summarize that for the video. Y, if we've got a function y is equal to a constant times sine of another constant x, we're looking at this entry in the table for sine ax. So dy by dx equals a, the a comes outside, then sine ax. That should be cos ax there. That's cos. So taken this one, the 4 comes outside and multiply times the 3. We change to the cosine of a times x. Multiplying that out is 12 cos 4x. Cosine function changes to a minus a times the sine of that function. So in this one, 3 comes outside and becomes negative. And then we're sine 3t. So it's minus 3 times 2 is minus 6. All happy.
Happy.
I'll take. Yeah. Right. Still struggling with this bloody file. I'll tell you what it is. It's my blinking iCloud is full.
Oh,
So I can't
you're
get
not
the
paying
file
your,
across.
are you paying your 50p a month for a bit more?
No, I'm not.
Ah, neither am I.
I'm tight on.
So am I, yeah. Not worth it.
Just need to take some stuff out of it, that's all.
Too much porn.
Right. You won't find none of that on my computer. Right, I'm back sharing the file again. So we move on now. Have a look at these ones. So we've got exponential function, 3 times 5 e to the 5x. We've got one where the exponential function is on the bottom of a fraction. We might need to have a little bit of a think about. And we've got a natural log function. So we'll just have a look. We've got those entries in the table. Yes, if we've got e to the ax, we bring the a outside, and it multiplies. That's why e to the x is a special function, because the derivative of e to the x is e to the x. And then you've got the log in there as well. So have a go at those ones, and I'll have another try trying to get this correct file across. All right?
Yeah.
Help each other, talk among yourselves, yeah.
Okay. I'll do the last one. Who wants to do the second one, and who wants to do the first one?
Share content, whiteboard. Right. So what have you tried with a? We've got y is equal to the 3
Taylor's got the answers.
e to the 5x.
Yeah, do you do the 5 times 3 to get 15e, and then do you just leave the 5x the same?
That's right, yeah. So you bring the 5 down, so you got 5 times 3, and then the rest of it stays as is. So it equals 15e to the 5x. Yep.
Yeah.
B. How do we do B?
I think Toby's got this one.
We've got f theta is 2 over e to the 3 theta. Remember what we had to do with the functions last time, where we had x to the power on the bottom of a fraction. We have to write it as 2e to the minus 3 theta. I have to write it in that form.
Yeah.
Yeah. And then we can say d theta. Oh, sorry, we're not in that kind of format, are we? Then we can say f first differential of that function is equal to then the minus 3 comes outside, multiplied by the 2, e to the minus 3 theta equals 2 times 3 is minus 6, e to the minus 3 theta. Yeah. And then if you want to, you can bring that exponential back underneath, so it becomes minus 6 over e to the 3 theta.
But can you leave it as a 1 before?
Yeah, you can. If you left it like that, or you moved it to that, there's both are the right answer. All right.
Oh yeah.
Okay. And then lastly, C, we've got y is equal to 6 ln 2x, and in the table ln x is 1 over x. Yeah, so we got, hang on, so there's, in the table you've got ln x, ln of ax is 1 over x, so it goes, so when you do this, we keep the 6, yeah, because that's a constant multiplier, and then that's just times 1 over x, which is equal to 6 over x. Simple as that.
Simple.
Okay. Everybody reasonably happy with that? Yeah.
Perfect.
No dissenting voices, so I'll assume that everything's okay. Right, I'll just go back to sharing the other file for a minute.
Oh yeah, diamonds.
Okay, so that's covered all the basic functions that we will the differentiation of all the basic functions that you would be expected to do. So you won't be given any basic functions outside of what's in that table. Yeah. But what we need to move on to now is being able to differentiate using formulae for differential calculus. So there's 3 different rules we're going to cover. We're going to start off with the product rule. So if we have a function y that is equal to u times v, where u and v are both functions of x. Yeah, so if we've got a function of x multiplied by another function of x, we have to use this formula to get to the answer dy by dx. All right, and that what you've got to do with that won't really become clear until we do an example. So that's what we'll do. We're then going to cover the quotient rule, which is where we've got one function of x divided by another function of x. And then lastly, we'll do function of a function. This is where you've got one function, and inside that function, there's another function of x. So something like the cosine of x squared would be a function of a function. Okay, so we're going to work on examples of each of those. So the first one we're going to look at is y is equal to 3x squared times the sine of 2x. So looking at that, 3x squared is a function of x. We know how to differentiate that if we wanted to. And then sine of x is another separate function of x, and there's an assumed multiplication sign between them. So we've got a product there. Yeah. So there's a procedure that we need to go through to differentiate that using this formula. All right. So just going to go back to sharing my whiteboard, and then I'll show you how to do it. All right. So what we have is, let's just put this formula up in the corner. We've got dy by dx is equal to u dv by dx plus v du by dx. That's the formula that we're eventually going to use to solve this problem. All right. What we have to do is we have to say, and the function we're trying to differentiate is y is equal to 3x squared times sine 2x. Yeah. So what we have to do here is say, let u equal 3x squared. Okay. And then we differentiate that. So du by dx is equal to, and we differentiate that, remember, by bringing the 2 down. So that's 2 times 3 is 6, and we take 1 off the index. So it becomes 6x. Yeah. Okay. Everybody follow that?
Oh, yes.
All right. And then we let v equal sine 2x. Yeah. And then we differentiate. So dv by dx is equal to 2 comes out, cosine 2x. What we've got now, just going to change my colour, is here we've got everything that's in the formula. We're saying dy by dx is equal to u. We've got u. We've got dv by dx. We've got v there. And we've got du by dx. So we put these values here into that formula. So we can go dy by dx is equal to u. What did we call u? 3x squared. Always put these in brackets to start with. Times dv by dx. So that's times 2 cos 2x. Yeah. And then we've got a plus sign. I'm going to put 9 underneath because I'm running out of room. We've got v, which is sine 2x. And that's multiplied by du by dx, which is 6x. Yeah. So once we've done that, we can bring any kind of like terms together. So we've got 2 constants here, 3 and 2. So we can make that 6x squared yeah, times cos 2x plus 6x sine 2x. Okay, and the last thing we could do if we wanted to is take 6x outside brackets with x in there plus sine 2x. Oh, hang on, I missed my cos out. Can't do that. X, 6x cos 2x plus sine 2x. But be more than happy with this version as an answer. If you wanted to use that to find the value, then you'd be able to do that. All right, so if you're using that in a problem, you get the same answer using this version as you would that final simplified version that comes from the Bird book. Okay? Everybody
Okay.
happy with that? Yeah.
Yeah.
All right, now the next problem in your notes that I've given you is one where it's just add on a little bit to it because I'm saying find the value of the remember what the differential is rate of change of a function. Yeah. So this question says find the rate of change, so it means find it's going to be dv by dt, they're the variables used for v is equal to 5t sine 2t volts. So let's find the value of dv by dt when t is equal to 0.2 seconds. So it wants to know what the rate of change of voltage is at time is equal to 0.2 seconds. So our function here is one function of t, 5t, times another function of t, sine 2t. So we've got to use the product rule. So what do you think you'd let u equal? Let that equal 5t. And then we differentiate it. du by dt is equal to, well, the index here is 1. We don't normally write it. So the 1 comes down and multiplies. So it's 1 times 5. And we take 1 off the index. So we got t to the u, anything to the power of 0 is 1. So the differential of 5t is just the constant 5. And then we let v equal sine 2t. So dv by dt, using the table, 2 comes out, function becomes a cosine 2t. Yeah. Then we put all that in the formula. So we've got dv by dt is equal to, and that's u. So that's 5t times dv by dt, 2 cos 2t plus v sine 2t times du by dt, 5. And we can tidy that up. We got 2 times 5 is 10t cos 2t on that side, plus 5 sine 2t on that side. And we could, if we wanted to, take a 5 outside, 5t cos 2t plus sine 2t. Right? Everybody happy with that? Oh, hang on. No, I'm not happy. I'll leave it like that. Then we're going to put into this t is equal to 0.2 seconds. So dv by dt at 0.2 seconds equals 10 times 0.2 times the cosine of 0.4 plus 5 times sine 0.4. And please check this, but your answer should be 3.79. That's volts per second. That's to 3 significant figures. So there's an added little bit to that, is actually find the value of the differential at a given value of t. Okay.
What's that bit after the cos? I can't read that.
What this here?
You got 10, yeah, that bit, yeah.
That's 0.4, it's 2 times t.
That is it.
Yeah, let me make it a bit neater. All right. So in your notes, you've got some product functions to have a go at. So I'm going to give you 10 minutes to have a go at some of those now, and then we'll look at the answers. All right. Well, these should be the answers that you get. Okay.
How come it changes from 0.2 to 0.4?
Because it's 2 times 0.2.
Oh, right. Oh, yeah.
Here you've got 10 times t, which is 10 times 0.2. Then you've got the cosine of 2t, so 2t is 0.4. All right?
Yeah, but is that not the same? Actually, no, yeah, that's good.
Do you see that, Connor?
Yeah.
You're starting off with 10t, aren't you? At the beginning. Yeah. All right.
Yeah.
So that's 10 times 0.2. But then inside the sine and cosine functions, it's got a constant times t, 2 times t, so that's 0.4.
Yeah. All
right?
Yeah, I get that.
Yeah. So till 25.2, have a go at those product problems on the page.
Okay.
Which number are we going for again, sorry?
There's on the, I don't know what page number of your notes is. After that problem we've just done, there's an exercise, further problems on differentiating products.
Oh yeah, I see it.
Yep.
All right.
Zoom recording, there we go. Right, so first problem. Did you get the answer that Mr. Bird gave you?
I believe so.
Yeah, these solutions are a bit short, but
Yeah, I went the long route.
yeah. Anyone want me to go through one or two?
Yes, please.
Right.
How does he do it there? Is that
Well, what he's done is he hasn't done it piece by piece like I did it when I show you solutions. He's just written out the solution. So he hasn't written down let u equal, let v equal, and shown the differentiation. Just done it and put it in the solution. Let me stop sharing that for a minute. And share whiteboard. So the first problem is, so we're doing number 1, 2x cubed cos 3x. We would let u equal 2x cubed. So du by dx is, bring the 3 down and multiply, 6, x squared, take 1 off the index. Yeah. And then we'd let v equal cos 3x. So dv by dx is equal to 3 minus 3, sorry, sine 3x. And then we just place all of those in the formula. So we go dy by dx, if we call that y is equal to, sorry?
How come it's minus?
Because when you differentiate with cosine, going back to the table, I'm just checking, when differentiated cosine, so the entry in the table for cosine of x is minus a times the sine of x.
Right.
Yeah.
Oh yes.
Mike, can you let Logan back in?
I can do that for him, yes. I can, I think. Where is he? I didn't even know he'd left. Can't see him now. Ah, there he is. Admit. Right, he's back in. Sorry, Logan. So we've got to put this in the formula. So we want, first of all, u, 2x cubed, by dv by dx, multiplied by dv by dx, so that's minus 3 sine 3x. And then we're doing a plus. We want v, which is cos 3x, times du by dx 6x squared. Yep. And then we can do some simplifying. So we got minus 3 times 2 is minus 6 x cubed sine 3x plus 6x squared cos 3x. And I probably think in Mr. Bird's solution, he's put the left-hand part on the other side. He's took 6x, 6 outside, and x squared outside some brackets, and then he's put this half over the other side, so the sign in the middle is negative. So he's got cos 3x minus x sine 3x.
Can you how would you
How's he
write
done
that?
that then?
How would you write that in the way you wrote it before?
What, up here?
No, like for the previous question, we didn't have. We wrote it like we kept the x sign on the left hand side. Or do you have to? Oh wait, did we? I don't know what we've done. Just ignore me. I'm just talking rubbish.
Yeah.
Yeah.
But you can see why the negative has become a negative sign in the middle of the bracketed function, because you've shifted the cos 3x over to the other side.
You
And
have
just
to
take
shift
that.
it over.
Well, you don't have to. No, you could quite easily write this final answer as 6x squared, yeah, minus x sine 3x
Oh yeah, because that's how I
plus
wrote it. Yeah.
cos 3x. It's the same
Yeah.
thing, okay? Just changing them round tidies that up a bit, because you're not tending to lose that leading negative sign here.
Yeah,
But
that's
if
how
you
I wrote it.
if you were looking to find a value of the derivative when x is equal to a value, then you could equally do that with any of these three versions here. Yeah. Okay.
Yeah.
We're usually going to be looking for some kind of a solution to a problem rather than the most simplified version of the derivative. All right. Do you want me to do one more?
If you want to.
I'll do this one with the log function, the next one. So we've got y is equal to root x cubed ln 3x. So we got a one function of x, which is the root of x cubed, multiplied by another function of x, ln 3x. Yep. So what have we got to do to this bit to be able to differentiate it?
Bloody hell.
So we're going to let u equal root x cubed, but we've got to write it as a fractional power. Do you remember doing that? X to the 3 over 2.
Okay.
Yeah. And then we can do du by dx is equal to, that's going to be 3 over 2 x to the half. Yeah. Everybody follow that?
Yeah.
All right. And then we'll let v equal ln 3x dv by dx is equal to 1 over x. Yeah. So therefore dy by dx is equal to, we want u, which is x to the 3 over 2 times dv by dx 1 over x plus v, which is ln 3x. Going to multiply that by du by dx, which is 3 over 2 x to the half. Yep.
I think Toby.
Sorry?
Yeah, Toby can help probably in this one.
I can help. What's wrong?
So how can we simplify that then?
Oh no, Toby.
How can we get to?
We can do.
Is that ln 3x down there in the left corner? We've let v.
Yeah, it is.
Yeah, buddy.
That's, yeah, this here is ln 3x. Yeah, do you want me
Yeah.
ln 3x? And when you differentiate it, it becomes 1 over x. Yeah. Just trying to look at this solution here. We can write this here as can't we?
Sure can. Why would we want to change it back once we've just changed it to that?
Sorry?
Surely we just changed it from root x to a 3. How come we're changing it back? Or does it just make it easier?
I'm just looking at this man's solution here. Yeah. I can. What he's done here is just get rid of that a minute. This this 1 over x here can be written as x to the minus 1. Yeah. So what you then end up with is here is x to the 3 over 2 minus 1. Yeah. If you write that 1 over x as x to the minus 1, should take away the index. And then we've got plus 3 over 2 x to the half.
Me confused.
Yeah. On that side. Yeah. So this becomes 3 divided by 2, take away a whole one. That becomes x to the half. Yeah. And that becomes 3 over 2 x to the half ln 3x. Now we got a common x to the half on both sides. Yeah, so he's taken that outside. Pair of brackets. Made that 1 plus and this is not minus a half, it's plus a half for this side. Plus ln 3 over 2, sorry. Ln 3x. And then here, this can be written as root x1 plus 3 over 2 ln 3x. Not the easiest one to do, I must admit. But if you're careful and look at it and you know your laws of indices for this simplification. But again, if it was in a problem where you're being asked to find the value of that differential for a given value of x, then again, any one of these would give you a valid answer. And one little tip is, if you're working on these problems I give you from the Bird book, and you can't find the simplification that he gives in his answer, because, you know, put the answer in brackets, then enter a given value of x in your function. So if you say let x equal 2, put that in your function and get an answer. Put the same x equals 2 into his function, and if you get the same answer, you're right, you just haven't simplified it in the same way as he has. Okay? Anyway, we haven't got quite as much done as I thought we might today, but that's
that's quality
not too
over
much of a problem.
quantity.
Quality over quantity. We'll pick up on that next time. All right, so I shall see you all at 2:15 this afternoon.
Yes.
All right, yeah. See you then.
See you later, Mike.
Wait,
Bye.
Mike,
Bye.
is there a handout
Yeah.
for next lesson?
I sent it to you via email yesterday.
I only got one for maths.
Oh, not this afternoon, not yet. No, that will
No.
be with you forthwith.
All right.
All right.
All right. Thank you.
Yeah. Okay. See you later.
Bye. I'll leave.